In this last lesson of the functions unit, we're going to examine the idea of an inverse function. An inverse function, which has this new notation, f to the power of -1, it's not really an exponent, it's more just notation, is the reverse of the original function. It's going to undo what the function did. Okay? So, for example, if we had the function 3x plus 4, by BEDMAS rules, we would multiply by 3 and then add 4. And that's what BEDMAS would do. To undo it, we'd have to do the opposite. We'd have to subtract 4 first and then divide by 3. So not only are we going to work our way backwards through the expression, we're also going to do the opposite operations. Okay? And just be careful with notation here, right? The function and the inverse function. Okay. The graphs of these two functions are directly related to each other. An inverse will have corresponding points with the original function, but there's something kind of tricky about them. The coordinates are going to be opposites. So for example, on my original function, fx, I've got the point 0, 1. On the inverse function, that point becomes 1 and 0. So the x and the y have swapped. They're not different signs, they're not different numbers, they're just in opposite order. Again, we have the point 3 and -2, and that point became -2 and 3. Okay, and then we got the weird one, -1, -1. When we swap that, we get -1, -1. Okay, so that would be an invariant point, right? It hasn't changed. But everything else swaps positions. When it comes to the domain and the range, the function and its inverse will be opposites of one another. So for example, if my domain for my function was x is, I'm going to move this a little bit. If x was greater than 0, and my range was -2 and y and 3, well, in the inverse, the domain would become the range, and the range would become the domain. Okay, so again, I haven't changed any signs. I've just swapped the x's and the y's. Okay. We're going to try some. We're going to look at lines for the most part for this unit. Okay, that we will do inverse of other things down the road, but we're going to stick with lines for now. So we're going to sketch the following. These are just lines, mx plus b. So our y-intercept is -2. Our slope is up 3 and right 1, up 3 and right 1, and then we can draw our line. That's our function. I want to sketch the inverse of that. So if I'm going to do the inverse, I kind of need to know some coordinates. So for example, 1, 1, and 2, and 1, 2, 3, 4. And if I want to get some more, so I got 0, -2. The inverse, I'm going to swap my coordinates. So 0, -2 becomes -2 and 0. 1, 1, that's still 1, 1. And 2, 4 becomes 4, 2. So my inverse will look like this. Now one more idea about inverses. An inverse is actually a diagonal reflection. If you were to divide this line like this, the graph, it's actually been diagonally reflected across that line. Okay, we want to state the inverse, state the domain and range for each of these functions. Well, the nice thing is they're both lines, so that make our life easy. So for both functions, for fx and inverse, our domain is all real numbers. It's almost like a trick question here. And our range is all real numbers. They're both lines, right? And part 4 says, are the inverses functions? Well, what do you think? If we did the vertical line test, would that be a function? Sure it would. Our vertical line test would only pass once, so yes, a function. Okay, you guys can try part B, but pause it, give yourself a try. Okay, we start at -4. We have to go down 1, right 1. Now it's going to go off my graph, so I'm going to flip it around and go backwards to get a few more points, make sure my line stays straight. There's my function. Okay, I want to do the inverse. So I need to think about my points. This point was 0, -4. So I need -4 and 0. What's another point I know? I know this point here was -1 and -3. So I need -3, 1, 2, 3, and -1. Huh. Interesting. Just to make sure, let's try another point. -2 and -2 is that point right there, right? Where's -2? It's the same point. So when I draw the inverse, ooh, sorry, I missed. When I draw the inverse for this one, what do I notice about these two lines? In this case, they're actually the same line. If you think about that diagonal reflection idea, one line's been folded on top of itself. Kind of a weird one. Okay, domain range, well, I'm going to cheat. It's this. Is it a function? Sure is. They're lines. And we know lines are functions. We know the domain range are always all real numbers. Okay, so that's a weird one that doesn't quite fit. So we get an idea of where we can take this. This is a parent function, one we're familiar with, hopefully. Okay, this is the v, but it's the v that's been moved down 2. Okay, so if I wanted to, I can make myself a table. What would my table look like? It would be -2, -1, 0, 1, 2, 2, 1, 0, 1, 2. And we need to transform that, right? This would be my new function. I want to move down 2, so y minus 2. Now you're probably asking yourself, well, why are you making a table? This is an easy one. I can just count. And sure, if you want to count, that'll work totally fine. The reason I made the table is so I can use it to do the next part, the inverse part. So there's our function. That's fx. And by fx, I mean this entire thing, okay? What's the domain of that thing? The range is, sorry, domain's all real numbers, and the range has got to be greater than -2. Okay, let's do the inverse. Inverse, I'm going to swap. X becomes Y, Y becomes X. Don't change numbers, don't change signs, just change the order. Okay, that one's the same. This one is that. Okay, let's graph it. 0, -2. That's down here. -1, -1. That's right there. -2 and 0 right there. Oh, it looks like it's on top of itself again. -1, 1. Oh, that's in a different spot. And 0, 2. That's in a different spot. So my inverse looks like that. Okay, it is a diagonal reflection. You can see it. And think about that line, the imaginary line down the middle here. The blue line became the red became the blue. Our domain, I can swap. So I think it should be greater than -2 for the x's now. And I think the range should be all real numbers. I'm going to swap this here, this here. Let's check it out. Does it match the picture? X is definitely less than greater than -2. And Y goes up forever and down forever. So yeah, that seems to work too. Okay, let's talk about the equations. To find an inverse equation, we need to start off by doing the same thing we've been doing. That is, swapping x for y. Once we've done that, we need to rearrange and get y by itself again. So we can do the operations. Okay, so I'm going to make my x my y my x. I just swapped the order, okay? Now I want to get x by itself again. So I'm going to undo BEDMAS. If I undo BEDMAS, think of it as Sam, Deb. I undo any subtracting or adding first. So I bring the 2 over. Then I undo any multiplying or dividing. And then I get my inverse. Okay, so you would normally write it like this. And you check it. Have I undid what I used to do? BEDMAS rules for the original function says multiply by 3 and then subtract 2. If I undo that and work backwards, I have to add 2. Yep. And then divide it all by 3. Yeah, perfect. Okay, we'll try the last one here. This one often causes a little bit of confusion because of the way it's written. Okay, we need to be kind of comfortable with moving things around. I hope you guys would agree this is the exact same expression. I haven't changed anything except for changed the order it kind of looks in. Okay, 2/3 of x is the same as saying multiply by 2, and then divide by 3. And so I can turn that into here. Why would I want to do that? Well, it makes my inverse a little bit easier. So we're going to swap. We're going to undo BEDMAS. So let's take care of the adding first. Let's take care of the dividing next. Okay, so it says divide by 3 on the right. So let's bring the 3 this way, and it becomes multiplying by 3 on the left. I want to get y by itself, so I need to divide by -2. So I need to divide by -2. And if you will, we can rewrite this in a variety of ways. I can write it as that. There's my function. Or, as we'll often see, in fraction form. Okay, so this says I should subtract 5 and then multiply by -3/2. Is that the opposite of where we started from? Before we was -2/3, the opposite is 3/2. It was add 5, and now we're subtracting 5. So yeah, it's perfect. Okay, now these inverses aren't very complicated right now. These are just lines. They're still going to make lines, but we're going to use them down the road for quadratics also. Okay, last question. I think it's the last question. Let's just check. Yeah, last one. I want to, oh no, second last one. I want to use an application of this. So we got Ben. He uses a rule to convert centimeters to inches. Multiply by 4 and then divide by 10. Can we write this as a function? Okay, so as a function, gx, we got to multiply by 4, and then we got to divide it by 10. Or, yeah, it means the same thing, right? I just like the fraction form. Can we describe a situation in which the rule for G inverse might be useful? Well, let's think about the function in the first place. Centimeters to inches, a metric to an imperial situation. When would I want to do the opposite? Well, maybe I want to go from inches to centimeters. I want to undo what I did originally. Can we figure out the equation for the inverse? I hope so. We have to undo what we did. So what's that going to look like? Okay, our inverse. Let's swap the x and the y. Now don't forget, a function is like saying y equals, right? So x equals 4y divided by 10. Let's get y by itself. I need to get rid of the divide by 10. I make it into multiplying. Need to get rid of the multiplying, make it into dividing. So my inverse would be 10x over 4. Or in other words, multiply by 10 and then divide by 4. And that's how you get from inches to centimeters. Now we're at the last one. Okay, symbols. That's really what this is all about. Can you find me, given this function, this value? What's that asking us to do? Well, it's actually asking us to do two things. It's saying find an inverse and then evaluate at x equals 2. That's all it's saying. It's just not using the words. So let's find the inverse first. Here's my y. Let's swap them. Let's rearrange it. And now I've got myself an inverse function. My inverse function, oops, that's not an equal sign. My inverse function looks like, that's not 2, it's a 4. This. If I want to find the inverse at 2, can I do that? Sure I can. My inverse, using some function notation here, 2 minus 5 over 4 gives me -3/4. That means on the inverse, there would be a point 2 and -3/4. That'd be on your inverse, right? On the original function, you actually know now that there would be a point at -3/4 and 2, because they're swapped. Okay, that's our last idea for functions. Here's your homework you can try. Again, try these ones. Some of them are about pictures, some of them are about domain range, some of them are about the equations. The big idea is that we can swap the coordinates, the x and the y. Don't change signs, don't change numbers, just swap the order.